Hello dear students, in this lecture we are going to discuss magnification. Magnification is so important, we will discuss its two formula and it is not just important for problem practice, rather it is also important to understand the type of image. Means just by seeing the value of magnification you can conclude what could be possible type of lens, its nature, image nature, position and etc. All the things we can just conclude just by seeing the value of magnification. So let's start our discussion with this formula. Magnification is denoted with M. So M here is equal to, we will discuss its true formula. Magnification is equal to the ratio of image distance to the object distance. In the last lecture, we have already discussed sign convention. So this is equal to height of image, ratio of height of image and object. Similarly, this will be equal to image distance by object distance. Okay, so this is the very important formula. Okay, very important formula. This is. Now, what could be the possible value of magnification? Let us write that magnification, or you can say M, can be, it can be positive or negative. Okay, magnification can be positive and negative, and in terms of its value, M can be greater than 1, equal to 1, or even equal to 1, I mean, or even less than 1. Okay, so these could be the possible value of M. Now, the important thing which we should learn here is that what could be the possible type of lens, or you can say nature of image, just by seeing if our question is asking us, or it is given in the question that magnification of a lens is plus 0.5. Okay, so what we will conclude in that situation, let us discuss them in more detail. Okay, so let us see. Here we can write a few cases, all the cases we can discuss. We will discuss all the cases, consider what could be the possible chance when M will be positive, when M will be negative, and similarly all the cases when M will be greater than 1, smaller than 1, or equal to 1. So let's take all of these one by one. Let's consider the case when M will be positive. Now, what can you conclude from this point that M is positive? So, about the lens, you can say it can be convex or concave. Whenever the magnification is convex, whenever the magnification is positive, then lens can either be convex or it can be concave. Let's discuss how many cases are possible for each one. So when magnification is positive and lens is convex, then the case here will be only one case. Only one case is possible. Let's further discuss that. When object is between focus and optical center. Okay, so this is the case. If the magnification is positive and lens is convex, then only case which is possible is when object is placed between focus and optical center. And what about concave? For concave lens, you can write magnification is always positive. So means if magnification is positive and lens is convex, means this is always true, means uh, if I mean to say here is that if magnification is positive, then concave lens could be that lens. or if the lens is convex, then there must be only one case when object is placed between focus and optical center. Okay, similarly we can write about the nature of the image. About nature, you can write image will always, nature of image, I mean to say nature of image, of image, nature of image, it will always be virtual and erect. Means you can conclude if magnification is positive, then the nature of image will always be virtual and erect. Okay, so this is the important case. Now let us take when magnification is negative. When magnification is negative, first of all, magnification negative means the lens will only be the convex one. Okay, lens is always convex lens. So if magnification is negative, then it is the only case that the lens will be convex. Okay, lens will be convex. And further, you can write all the cases means when object is not between focus and optical center. All the cases except this case will be the case in which magnification is negative and the lens is convex. There is no scope that the lens will be concave and magnification will comes out to be positive. Okay, magnification positive we have already discussed. So okay, so this is very important points. This is very important, you can say conclusion we can draw from these points. Positive negative we have discussed. Let's discuss the same for values of m. Means if m will be positive, what will happen? Means m will be greater than 1. Now if m is greater than 1, so what we can say about that? The lens will be convex. Lens will always be convex. Then only the magnification will be greater than 1. And all the cases we can say about it is object must be between 2f1 and optical center. Okay, so this is the case. If the magnification is greater than 1, then what can you conclude? That the lens will only be convex, and what could be the position of object? It will be between 2f1 and optical center. Okay, so this is important case. Let's write the same for the case when magnification is less than 1. In that case, lens can either be convex or concave. Okay, so let's discuss the case about convex lens. When object is placed beyond 2f1, means all the cases except this, apart from these cases, all the cases in convex lens will fall in this category when object is placed beyond 2f1, means between 2f1 and infinity. Okay, so this is the case. And about concave lens, it will be less than 1 in all the situation, always you can say. Okay, and the last case is when m is equal to 1. Here it will be only one case, so we can write when lens will be convex and object is placed object is placed exactly at 2f1. Okay, so these were very few important points about magnification. I hope you must have learned a lot about this points you will keep in mind and apply the same for problem practice as well as in conceptual problems. Okay, so that's it for this lecture. Thank you so much.